This in basic integration, how to integrate a given term or expression. Then we added a constant c and we had one set of value to find c, and this was up to exercise 13D. C. So what next did we discuss? Definite integrals, upper limit minus lower limit, and we practice few parts from this exercise 13D. Okay, now let's try question number 3 and then we'll come on to new concepts. Question number 3, let's say, let me try part A. It says 1, 2, 3 x cube plus 2x square over x dx. Evaluate the following definite integrals. Now limits are given and we are going to integrate the given expression. So first we simplify x cube over x plus 2x square over x dx, and the limits are 1 to 3. So 1 to 3 I have x square plus 2x dx. Now this is simplified. I'm going to integrate this part. Integration is power plus 1 divided by new power plus 2x square power plus 1 divided by new power from 1 to 3. Now this is being integrated. Simplifying it before I substitute the values. This is 1 to 3. Now upper limit minus lower limit. First we'll substitute 3. So 3 cube over 3 plus 3 square. Upper limit minus 1 cube over 3 plus 1 square over lower limit. And simplification. So 3 cube is 27 by 3, 9 plus 9 minus 1 by 3 plus 1. So calculator, minus 4 by 3 calculator is not working. So 50 by 3 unit square. If units are asked, it is unit square. Now look at this question number 4. It says given that a is a constant, limits are given 1 to 4, 6 square root minus a is equals to a square. Show that there are two possible values for a. Find these values. So first we'll simplify the question a bit using the limits and integration, then equate it with a square. So question number 4 is 1, 4, 6 square root x minus a whole dx is equals a square. So when we integrate it, so may I say this is 6x 3 by 2 over 3 by 2 minus ax limit 1 4 is equals to a square. Any issue in this first step? And then simplifying is 4x 3 by 2, not sure, okay. This was 6x square root. We can write 6x 1 by 2. Now integrating. So when you integrate, you add 1 to the power and divide with the new power. So this becomes 3x 3 by 2 over 3 by 2. Then we simplify these numbers in next step. Clear now? Now we have upper limit and lower limit. So when we put upper limit, we get 4 into 4 3 by 2 minus a into 4. This is upper limit minus lower limit. 4 into 1 3 by 2 minus a into 1 is equals to a square. So 4 square root is 2, 2 cube is 8, 8 4 times 32 minus 4a minus 4 minus a is equals to a square. And we keep on simplifying. 32 minus 4a minus 4 plus a is equals to a square. And then we rearrange. A square is already there. 4a and a minus 3a. Take it on the other side, plus 3a. 32 is there, minus 32 is equals to 0. And factors for 32. 1 into 32, 2 into 16, 4 into 8, what are the possible values? If not discrete, we'll use quadratic formula. Eight and 4, no. 16 and 2. I'm using quadratic formula. Minus b plus minus square root. B square minus 4ac over 2a. Can you please help me with the calculator part? Minus 3 plus minus 3 square minus 4a c over 2a minus 32. So these are the two possible values. First is minus 3 plus square root 139 by 2. Next is minus 3 minus 139 square root by 2. Any issues? So as the question, we integrated first, then substitute the upper limit minus lower limit, and then this was just a simple quadratic equation. Upper limit, lower were given 4 and 1. This is the main scenario. Whatever the equation of the curve is, for example, you have this curve, so I'll call it y. You have the equation and you are given the limits. 1 and 7, and you're asked to find this area. So this area is actually equal to integral of y with respect to x from 1 to 7. Whatever the equation will be, we'll replace this in place of y. And these limits could be anything, positive, negative, both positive. Copying the same curve, the limits could have been -2 to 5. So area of this section would be integral -2 to 5 lower limit and then upper limit y dx. Integration gives you the area under the curve and bounded by limits and x-axis. Now what would happen in this case if you have this question and you know that this is 2 and this is 4? If in this case you get a negative answer, we'll just write a statement that area cannot be negative. Let me assume a simple question and let's solve it. For example, I have a question which passes through -3. It would be y is equals to x square minus 3. And let me assume that we are solving from 1 to 1 and finding this area. So area would be equal to integral -1 to 1 y dx. General form. Now substitute the equation -1 to 1 x square minus 3 dx. Now we integrate x cube over 3 minus 3x and 1 minus 1. Next step, upper limit minus lower limit. First we substitute 1 by 3 minus 3 into 1. This is upper limit minus lower limit. Minus 1 over 3, this is cube, minus 3 into -1. Now we simplify this. So we get 1 minus 9 minus, this is -1 by 3 plus 3. -8 by 3, 3 minus 1 plus 9, -8 by 3, and this is plus 8 by 3. You see, -8 by 3, -8 by 3. Are getting the idea? Now the final value is -16 by 3. What actually happened? This lies below the belt. Area above the x-axis is positive, below the x-axis is negative. So we'll just write a statement 16 by 3 unit square and say area cannot be negative. Now having said so, we can assume that if we have a graph which would look like this, and there are 3 points of intersection: A, second point is B, third point is C. So let me say the graph is symmetrical and this shaded area is Q. So this will be Q again if the graph is symmetrical. Now if we perform integration from A to B, we will have this answer. If we perform the integration from B to C on the same curve, we'll have this answer and we'll write it as Q. And if we perform integration from A to C, I'm slowing down here. Before I write the answer, I want you to compare the previous two. From A to B, we are talking about this part. From B to C, we're talking about this part, and now at the end we are talking about this whole collective. Integration would give you 0 for this, because it is handling the area, positive area and negative area, and you can see for yourself that the area is not 0. So in these such cases we will solve them separately from A to B and then from B to C. Getting the point? Because of the same reason, let's look at this graph. We found this area, this shaded area, which came out to be negative 16 by 3, and we changed it to positive 16 by 3 and saying that area cannot be negative. So it is lying below. This negative sign actually tells you that it lies below x-axis. Now for a new concept, what would we be looking at? There will be 2 equations, not 1. For example, we have this equation and we have another equation in blue and red. So this is y and this is y, 2 equations. Now the examiner may ask you to find the area between the 2 curves. Now this would be a little extended question. First you will solve them simultaneously to find these 2 points of intersection, which is A and B, to have your upper limit and lower limit. In this case what we will do, let me replace this A because I have to use it as area, C and B. So area would be equal to integral, lower limit would be C, upper limit is B, and what do we integrate? We integrate the upper curve minus the lower curve with respect to x. We know this blue part lies above this, so we write it here. Then we know this red part lies below this, and we write it here. Now I'm extending it. For example, we solve only for the blue section. Exact same question. So you know you will be getting this area. And if you solve the same question for the red section only, we know we will be getting area under the curve. So area under the blue curve is actually more. If I shade it with yellow, area under the blue curve is this, and area under the red curve is this. So when you subtract these two, you will get the area bounded by the 2 curves. Getting the concept? So we'll integrate upper curve minus lower curve. In this case, I know which curve is upwards, which curve is downwards. So when you will have 2 equations only, for example, y is equals to x cube minus 2x square plus 3, and the other is y is equals to x square plus 5x minus 7. Now we cannot say which curve is upwards, which is downwards. What will happen? We will do it in any order. One student will get an answer of, suppose, positive p, other is getting negative p. Value would be same. What is happening here? Someone did this 1 minus 2, the other did 2 minus 1, because you can only assume that this equation would lie upwards, just like in this case. And when you get the negative answer, you will change it into positive. Now let's write few simple questions and then solve. For example, this is let's make it even simpler. This is the first equation, y is equals to x square. This is the second equation, y is equals to 2x. And you are asked to find the area between the two curves. So how can we do this? First we need to find the limits. So I'll say x square is equals to 2x, and solving for values of x, so x is equals to 0 and x is equals to 2. So I know this is 0 and this is 2. Even if the graph was not there, the two equations were y is equals to 2x and y is equals to x square. We would have solved them simultaneously and get these two values. Now lower limit and upper limit. So what will I do? Integrate first equation minus second equation from 0 to 2 with respect to x and get the shaded area. Taking a pause here if there is any problem to discuss. Yes, Mohammed. We can do that. We will do that to compare. But in exam, we'll perform it only once. I'll do it 2 times here. Why I'm writing 2x minus x square? Because I can see that 2x is above it. Area under 2x is more than area under x square. The graph is given. I can see that. That's why I'm writing it. So let me complete. I'll solve it with the second angle as well. So 2x square over 2 minus x cube over 3 from 0 to 2. One step of simplification from 0 to 2. So upper limit is 2 square minus 2 cube by 3 minus lower limit is 0 squared minus 0 cube by 3. We can write 0 directly as well. So 2 square is 4 minus 8 by 3. 12 minus 8 by 3 is 4 by 3. Unit square. Now if we were given with these equations only 2x and x square, and we do not know which equation lies above the other, and we just decide to subtract them in this order, and we've already performed simultaneous equation on them and got the limits 0 to 2. We'll write 0 here and 2 here, dx and a. Now these are two different students. First method and this is second method. Now this would be x cube over 3 minus 2x square over 2 from 0 to 2. So x cube over 3 minus x square 0 to 2. 2 is 2 cube by 3 minus 2 square upper limit minus lower limit. Now we have 8 by 3 minus 4. So 3, 8 minus 12 minus 4 by 3. Compare these two. This is the only difference. At this stage, you will know that you've actually switched them. No need to solve the question again. This is 100% acceptable. No need to solve it again. Just write one more step. 4 by 3 unit square. Area can not be negative. Clear, Mohammed? Now there is one more way we could have done it. Copying the same question. Why are we discussing these possibilities? Every possibility is allowed in exam, and you will solve with the method you are most confident in. This was the question, and we have to find the area between these two curves. We've already performed simultaneous equation on them, and this was 0 to 2. Can you see that this straight line is actually a triangle? So if I substitute this 2 in y is equals to 2x, I can say that this vary coordinate is x2, y4. Only for this triangle, we can say this base is 2 units and this height is 4. So area of triangle would be 1 by 2 into base into height, which is 4 unit square. Any issues? And if I decide to subtract this area in blue from the triangle, I'll be having the area between two curves. Now I'm finding the area under the curve, which is x square dx from 0 to 2. So this is x cube over 3, 0 to 2, and we already know that upper limit minus lower limit is 8 by 3. Now you know area of triangle and you know the area under the curve, so you can subtract these two, full minus area under the curve. You will be left with area between the curve, between the two curves. So 4 minus 8 by 3 is 12 minus 8 by 3 is 4 by 3. So 4 by 3, this again is 4 by 3 and 4 by 3. You solve it with any method, it is acceptable. Is it getting clear? Please say that again. Yes, sure. Please just text your email and I'll add it. WhatsApp would be more easy for me. Now let's have a look at the book. We just did this. Vertical height x plus change in x. Now what this is, you know what x is? This is basically change in x. For example, I say x is 2 and then I say there is a change of 0.1, so this would be 2.1. So when x changes from 2 to 2.1, the area is also increasing. From 0 to x, the area is a, or 0 to 2, the area is a. From 0 to 2.1, the area is changing. So how much change in x is giving how much change in the area. And do not be confused with the words. For example, the same question again. At x2, we exactly know what this area is. So if it changes from x2, x equal to 2 to 2.1, we can find the new area and state so. Now area is positive because it lies above the x-axis. Question number 9. Example 9. Find the area of the finite region between the curve this and x-axis. Now limits are not given. It says between the curve and x-axis. So we know we have x-axis, we have y-axis. This curve would lie somewhere. Now I can foresee. You see, this is the this is actually solved question. So if you look at this x square, the coefficient is negative, so it would be a sad face. So just randomly sketch it anywhere. Even you don't have to suppose this. y-axis. So you just know this. So we are actually looking at this part. Now how will we find the limits? It says find the area between the curve and x-axis. Getting the point? Between curve and x-axis. So they actually intersect at these 2 points. So I have to solve these two. This is x is equal to 0. This is my one equation. Second is given in the question. When we solve these two, we get -5 and 4. These are your upper and lower limits. And there you go. Integration. All repetition. Integrate upper limit minus lower limit and you get the area. Any confusion? Not any. Now see. Yes, sure. As we did yesterday, that was differential is given. We do the integration, we put a plus c, we substitute the given point, we find c and we rewrite the equation. Now this is this same repetition. We have the equation, we do the integration, we substitute the limits and we state the area. One thing. Second thing, if we have two curves, one extra step. If we have two curves, we write first curve minus second curve and then we perform the integration, substitute upper limit minus lower limit and we state the area. What would be different in every question is the difficulty level. Concept is same. It says find the area between the curve x-axis and these two limits. So whatever the question is, I'll say area is equals to integral. Let's suppose we're talking about the first one. So minus 3x square plus 17x minus 10 from 1 to 3 with respect to x. That's it. Integrate upper limit minus lower limit. Look at this last part. Area is equals to integral 8 over x square dx from -4 to -1. So what do? Integrate upper limit minus lower limit and state the area. Look at question number 2. The sketch shows part of this curve. Find the area of the shaded region. So y is equals to x cube minus 4x. Now what do? Integrate x cube minus 4x from -2 to 0. -2 to 0. What's the difference? It was given in the question in writing form. Now this is given in graphical form. So what should we do? Just integrate x 4 over 4 minus 4x square over 2, upper limit, lower limit, that's it. Simplify and state the answer. Look at this question number 4. What are we doing? We need y to integrate and we need the limits a and b, right? And this question, find the area. Okay, I have this hint that area is equals to integral of y. And what are the limits of the finite region between the curve? Okay, we have the curve and the x-axis. Limits are not given. So one extra step, we will solve them simultaneously and solve for x. So x is equals to 3 and x is equals to -1. This was simple, so I can directly see what the values are. So lower limit -1, upper limit 3, that's it. We'll integrate it and have the answers. What question 7 has to say? The shaded area under the graph of function this is bounded by the curve and x-axis and the line 0 to k is 8. Now area is given, one of the limit is missing. Let's try this one. This is it's just a little different in writing. The nature is 100% same. So equation is y is equals to 3x square minus 2x plus 2. The limit is given 0 and k. k is unknown, and area is given, which is 8. So what do? We exactly follow the same nature. Area is equals to integral lower limit upper limit 3x square minus 2x plus 2 with respect to x, and now we substitute the values and perform the integration. Area is already given, that is 8. This is 3x cube over 3 minus 2x square over 2 plus 2x limit 0 to k. Simplifying before substituting the limit, x cube minus x square plus 2x 0 and k. Now I'm substituting k first. So 8 is equals to k cube minus k square plus 2k upper limit minus lower limit. So 0 in every part, we know it would be 0. So k cube minus k square plus 2k is equals to 8. Now we are going to solve this cubic equation. K cube minus k square plus 2k minus 8 is equals to 0. And we will solve this. You actually don't do that. For example, you have this question, x square minus 3x plus 6, right? We would look for midterm breaking. Suppose we have this plus 5x. What do is 2x 3x plus 6, one thing. There are more steps to it, but we don't do this. X square plus 5x is equals to 6 and take out x as common. Right? No. Yes. Yeah, sure. Annotation is allowed. This will not give you the solution because value of k is actually not equal to 0. Look at this equation, right? When you go for midterm breaking, getting the point? So in this second part, if I take out x as common, I'm left with x plus 5, and my solutions will be x is equal to 6 and x is equal to minus 5, which are entirely wrong, because it should be equal to 0 where it intersects the given situation. Okay, for example, I have this curve, and let me say when it is equal to 0, this is minus 2 and 8, let me suppose. And when it is not equal to 0, when it is equal to 8, this may be 12 and this may be minus 7. This could be anything. So this has to be equal to 0, the whole of the equation, and then solve for k. So first thing would be head and trial. Then we'll go for long division and solve the quadratic part. So this was it about integration and area under the curve and area bounded by the two curves. Now we already know that this would be negative, this would be positive, and we have three limits a, o and b. We will solve these separately. A to 0 separate, 0 to b separate, and then add them at the end. Just let me have a look if we have something new. Now this thing right here is a little extra. If you draw this vertical line, you will know this value of x, this value of x, and this which I just drew. And the part on the right is actually a perfect right angle triangle. So we will be solving this question in 3 different steps. First area, second area, third area, and then add them at the end. And that is it. There's no extra concept. Now we're left with practice. Tomorrow I will solve this exercise 13G with you, and I'm expecting that you should have a look at the first 5 exercises from A to E. Any issues? And I'll add your email,